All right, so the first thing I'm going to talk about, though, and I am tying some things in that will come in next year, and they won't be as much this year, but we'll tie it in a little bit next year. The first thing has to do with something called standard position. Standard position means the following. It means that you have a point at the origin, okay, 0, 0. So notice here point A is at the origin. Again, the origin is the point 0, 0 where the x and y axis intersect. Okay, and then if you look at the standard position for a right triangle, the following conditions are going to apply. The hypotenuse. Remember, the hypotenuse is the longest length, or the side opposite the right angle, is the radius of the circle. And it has a length of 1. So here the measure of this radius is a total of 1 unit. Okay, the horizontal leg of the right triangle is going to lie on the x-axis. Okay, that's this leg here. Again, here's the hypotenuse. It's a length of 1. And then the final condition is that vertical leg. Is going to be perpendicular to the x-axis. And again, that's right here, perpendicular. And what that would mean is it's going to be parallel to the y-axis. Okay, so if you are looking at a right triangle in standard position, you're going to start with a point on the origin. You're going to create a hypotenuse of 1. Your right angle is going to be your horizontal leg, your vertical leg. That's the right triangle in standard position. Okay, so that's just some terminology you might see, and that's what it's referring to. All right, the main things that you're going to need to know, and then for this first homework assignment, you're going to need to know the following calculation, and it's one that you are probably already familiar with. It's called Pythagorean theorem. The Pythagorean theorem states that in a right triangle, and again, it's only for right triangles, but in a right triangle, the sum of the squares of the legs is equal to the square of the hypotenuse. Okay, and so mathematically speaking, here, if we have legs A and B and a hypotenuse C, you have the equation a squared plus b squared equals c squared. So again, this is like a famous formula. It is an equation that you should already have known and worked with. Okay, but this is what we're going to be doing for this first section. Okay, and the calculations can be you'll be given 2 of these unknowns, either 2 legs, and you have to find the hypotenuse, or you're going to give the hypotenuse in one of the legs and you find the remaining leg. Okay, so I want you to try that calculation on your own first before I walk you through it to see, 1, if you remember it, or 2, if you haven't been exposed to this yet, can you follow just taking that formula and applying the numbers and solving for the unknown. So just try the question right below. I'll go through it here in just a moment, and then I'll give you a chance to solve the remaining question as well. Or you can enter your answer as a calculation. That's really helpful when you're working through these problems. It allows you to answer the questions pretty quickly. Okay, and oftentimes in future classes, you might be asked to simplify a radical into its reduced radical form. So you may not be able to enter that calculation. But this year, you can just enter your calculation. And so what you would find here for this first example, you recognize you have a right triangle. You have two of the measurements for the sides. You have a leg and a hypotenuse. So if you take a squared plus b squared equals c squared, which is true for a right triangle. If we say our a value is 4, our b value, the other leg, is our unknown x, and our c value is the hypotenuse. That's the leg opposite, or the side opposite the right triangle. You have your calculation, and it's just a matter of isolating your variable. So if we subtract 4 squared from both sides, and then we extract the square root. Now, normally when we talked about algebra or solving algebra equations, you would have to consider both the positive and negative root of this when you extract it, but can a triangle have a length of a side that's negative? No. So you can disregard the negative version of this, and so your answer is the square root of 11 squared minus 4 squared. So notice this is probably the simplest way to enter your answer. Now, if you enter this answer, you'll see the display give you an approximation for the decimal equivalent. That's fine as well. And in classes that you might have later, what you will be asked to do here is you would expand this out. So 11 squared is 121 minus 4 squared, which is 16. That gives you the square root of 105. There is no perfect square factor you can remove from 105. So you could have also entered your answer as the square root of 105. Okay, so this right here is the exact answer. This calculation is also an exact answer. This one would be an approximate answer. But again, any of those forms would be okay. All right, so I want you to try this remaining question here. See if you can find what is x in that problem. This time it is the hypotenuse. All right, so here you have two legs. Your unknown is the hypotenuse. You recognize you're dealing with a right triangle with two measures. So we can use Pythagorean theorem. A squared plus b squared equals c squared. If I say a is 9 plus my b value is 14 equals my c value, which is x, I can simply extract the root. Again, I can disregard the negative of these because it's a length. A length can't be negative. And so the easiest thing to do right here would just be to write my answer as a calculation. If I did that, I would get my decimal equivalent. And if I continued working through this, I would have seen that 9 squared is 81, 14 squared is 196. And if I combine those, I would get root 277. Again, there's no perfect square factors I can remove from this, so I would leave it in that form. So these would be the three acceptable forms of entering your answer. All right, how many of you have worked with Pythagorean theorem before? Have you guys done calculations with that? Okay, I assume that's one of the ways they introduced radicals to you last year in algebra. All right. So one of the other things that you might be asked to do is recognize what are called common triples or Pythagorean triples. Okay, the two most common ones are 3, 4, 5s and 5, 12, 13. Okay, what this is, a Pythagorean triple is the set of three sides of a triangle, or of a right triangle, that are all integers. Okay, so oftentimes, or most of the time, you're going to get a radical as one of your sides, either the leg, one of the legs, or the hypotenuse. Okay, but sometimes all three sides are integers. They're most likely going to be 3, 4, 5 by far. The second most likely ones would be 5, 12, 13s. But then there can be multiples of these all. Okay, so not only would 3, 4, and 5 work, but if you doubled each of those lengths, you might recognize 6, 8, and 10. If you tripled each of those lengths, you might recognize 9, 12, and 15. If you multiplied by 10, you would get 30, 40, and 50. These, any multiple of these common triples is also going to be a right triangle. Okay, so 5, 12, 13, same kind of thing. If you double it, you'd see 10, 24, 26. If you tripled it, 15, 36, 39, and so on. Okay, so that is one of the things that you're looking for because it allows you to answer your question without having to use a calculator. Now, can you use a calculator to solve it? Yes. Can you use Pythagorean theorem to answer these questions? Yes, but it saves you time if you recognize the patterns. And again, even though there's some other patterns, like the 8, 15, 17, 7, 24, 25, these are some of the other patterns. You don't need to memorize those. Just the 3, 4, 5, and 5, 12, 13. Okay, so how would you go about working with this to save the time and not have to use Pythagorean theorem? When you look at a right triangle, the first thing that you should do is look to see, are there any common factors between the numbers provided that allow you to see 3 and 4 as the legs, or 5 as the hypotenuse, or 5 as the hypotenuse, and 12 or 13 as the legs. So basically, if I look at this example right here, I see 36 and 27. Okay? I recognize that those have common factors. Now, you might start by seeing it has a common factor of 3, but look to see, if you take a 3 out of 36, that leaves 12. Okay, that might be a 5, 12, 13 pattern. So if you take 3 out of 27, are you left with 13? No. And you're left with 9. There's still another common factor you can remove from both of those. So 36 and 27 have a common factor of 9. So if you take out a 9 times 4 and a 9 times 3, notice you have this pattern. 3, 4 is the legs. That means the hypotenuse is going to be 5. And what's your multiplier? 9. And so our C value is 9 times 5, or 45. And so this allows you to answer your question without having to use the calculation of Pythagorean theorem. Now, had you solved this, had you said 27 squared plus 36 squared equals C squared, extract your root and entered this, that would display as 45. You would still find the correct answer. Okay, but if you can find the patterns, it just saves you a little bit of extra time. All right, so see if you can answer the question right below. Okay, can you find a pattern for that? And then can you apply that pattern to answer your question quickly? All right, so if I'm looking at a hypotenuse, first thing I would check for, is it a multiple of 5? Because 3, 4, 5 is the easiest one. 39 is not a multiple of 5. Okay, so let's check the 13. Is 39 a multiple of 13? Yeah. It's 3 times 13. Oops. All right. Okay, so if I take out that, oops. I'll take out a 3 times 13. So if I take out that factor of 3 from the other given leg, I have a 5. Well, is 5 blank 13 a common triple? Yes, it's the other common triple that you should memorize. 5, 12, 13 with a common multiplier of 3. 3 times 12 gives you 36. And so that would be the quickest and easiest way. Now, students won't always find these or recognize these, right? So if you were solving this, you might label as b squared plus 15 squared equals 39 squared. Subtract 15 squared from both sides, extract your root. And so once again, with the MyOpenMath system, entering your answer as the square root of 39 squared minus 15 squared is pretty easy also. Okay? And so you can just enter that as your answer, and it'll display the preview value of 36. All right, see if you can answer this final question down here. Okay, can you find what x is given the diagram that you see? I can give you a heads up. The homework problems that include the diagrams like this have like 6, maybe 5, 6, 7 different versions of diagrams that contain a right triangle in it. It's probably in your best interest when you get to that is to look at the similar questions or try similar questions on that to see what the different variations might look like when you're prepping for your quiz or test. Okay, because you will be given a random version of that question. And what you should look for in that is find your right triangle. So here's the right triangle for this pyramid. I see that I'm given a leg of 10, I'm given another leg of 24, and I'm given a hypotenuse of x. 17 refers to the whole side length of this, the base, this rectangular base. All right, so if I look at 10 and 24, I recognize that those fit the pattern of 5 and 12. So this is 5 times 2. This is 12 times 2. So I have a 5, 12, my pattern is 13 with a multiplier of 2. 2 times 13 gives me 26. Notice that this one does have a drop down. Some of them may have drop downs for units. I'm looking at a length. A length is a one-dimensional unit, and so this would just be yards. Yards squared would be an area. Yards cubed would be a volume. And working with diagrams like this is just kind of prepping you for the final kind of content area that we're going to cover, where we do deal with three-dimensional solids. And so it's just getting you familiar with seeing those diagrams early on. All right, so be prepared for working with Pythagorean theorem and right triangles. All right, the final slide and the final content, or the final topic that we're going to look at here is this relationship of how can you classify a right triangle based on what all three sides are. When you look at all three sides, you can determine whether that triangle is acute, obtuse, or right. Okay, now, finding the right triangle, or identifying a right triangle, is the easiest one, right? If you take the sum of the squares of the two smaller sides, so if you established that a squared plus b squared is equal to c squared, then you know you have a right triangle. Okay, so that's the easiest relationship, right? If Pythagorean theorem works, or the converse of the Pythagorean theorem is true, then you have a right triangle. Okay, let's look at the other two scenarios. So there's two other scenarios. A squared plus b squared compared to c squared. And that's just, the a and the b represent the shorter two sides. C represents the longest side. So a squared plus b squared compared to c squared. Right, so I tend to use like a visual for this. So imagine that these are your two side lengths, your legs, and then my hand is the hypotenuse. Okay, so here's a right triangle. My hand squared is equal to the sum of the squares of these other two sides. What if my hand squared, my hand represents the longest side. What if that length was bigger than a right triangle? What if c squared is greater than the sum of the squares of these? So imagine me growing this c squared. What happens to the triangle? What kind of triangle does that become? Obtuse. So if you have a squared plus b squared, where the c squared value is greater than it is in a right triangle, it extends out and it forms that obtuse triangle. Right, if we come back to that same illustration. So here, right here is your Pythagorean theorem. C squared is equal to a squared plus b squared. What if my c squared, my hand value, is smaller than it is in a right triangle? It pulls that down, and what kind of a triangle is created there? An acute triangle, right? Brings it in. So if c squared is less than then you're looking at an acute triangle. All right, so let's take a look at these calculations right here. Okay, I want you to see if you can identify this first set, 24, 37, and 12. Can you find out which of the patterns does that fit? Oops, let me finish writing these. All right, so if we look at this first example, remember, you're not just going from left to right, right? It's not A is 24, B is 37, C is 12. You're going to take the two smaller sides, square them. So if I look at, work for this first one, I have my smallest side 12 squared, my next smallest side 24 squared, and I'm comparing this to 37 squared. Okay, so if I calculate these values here, okay, so 12 squared is 144, plus 24 squared, 576, 37 squared, 1369. And so I can see here, I don't even need to continue this, and I see that 1369 is greater than 144 plus 576, right? You don't need to know the exact values, even though you can find them. All right, so based on our relationship here, the longest side squared is greater than it would be in a right triangle. So does that give us acute or obtuse triangle? What if I told you the answer is not obtuse? Can anybody tell me why is the answer to this, why is it not an obtuse triangle? It fits the rule that we talked about, but that is not the correct answer. Can anybody see why that might be the case? It's a trick question. Does anybody remember what this is? So this doesn't even fit the actual conditions of triangle inequality, right? Remember, one of the other conditions of a triangle is the sum of the two shorter sides has to be greater than the longest side. Is 12 plus 24 greater than 37? No. So this one's not even a triangle. Now, that's a trick because you guys don't see that as an option, right? I didn't show you what the drop-down shows. So the drop-down is going to be acute triangle, right triangle, obtuse triangle, and the other option is none of the other choices is correct. Okay? And so that, when you see that version, it's basically saying that it doesn't fit the conditions of triangle inequality, and the two shorter sides will not even meet to form a triangle. All right, so that's the only trick one here. See if you can answer the remaining three, actually following those rules that we established. And can you find which of the following is acute, which is obtuse, and which is right? The other thing that you will find is that relationship is only true when you do the calculations in these inequalities to compare them. That's only going to be true if it would otherwise be an obtuse triangle. So anytime you get obtuse triangle as your answer, kind of cue into and verify that triangle inequality works, or that condition is met. For acute and right triangles, you don't have to worry about that. But obtuse ones, double check it. All right, so here, if you took 28 squared plus 45 squared, you're going to get 2809. When you square 52, you get 2704. And so what you see is the longest side squared is less than it would be in a triangle. Again, I'm kind of using the reference of the smallest side squared versus it's less than. Less than means it pulls in and it becomes an acute triangle. It's smaller than it would be in a right triangle, which makes it acute. If we look at the next example, the two shorter sides are 12 squared and 34 squared compared to 37 squared. When we make this comparison, 12 squared plus 34 squared gives you a total of 1,300 compared to 37 squared, which is 1,369. We see that the longest side squared is greater than it would be in a right triangle, and we saw that pushes that longer leg pushes the angle open to be an obtuse angle. So this is an obtuse triangle. Now, because it's an obtuse triangle, again, anytime you see obtuse, double check. Is the sum of these two smaller sides greater than the third side? Yes. 12 plus 34 is greater than 37. So triangle inequality is met, and that will be our correct answer. The final question here, look at the two smaller sides. 8 squared plus 15 squared versus 17 squared. When we do our comparison, we get 8 squared plus 15 squared is 289. 17 squared is also 289. When they are equal, that means you have a right triangle. Okay, so that's the last type of question that you're going to see here in this first set of homework.